Good day, everyone. So we are going to tackle about the answer keys for um, part 2 of the quiz 1. Okay, let's start with number 1. Evaluate the limit of the sequence as n approaches infinity, where an is defined by this sequence: 1/2, 2/3, 3/4, 4/5. So if we are going to continue this one, so this will be 5/6, 6/7, and so on, 100 to 101. No? So if we try to expand this one, as n approaches to infinity, this will approach to 1. So therefore, the answer here is 1. Or you may evaluate the limit of this one by transforming the sequence to its general form, and the general form of the sequence is n over n plus 1. So if we evaluate the limit by, if you recall your lesson in calculus 1, so if we evaluate the limit, so we factor out 1 over n on both sides, no? So we will cancel out 1 over n, and we will have 1 over 1 plus 1 over n. And if we evaluate the limit, so 1 over n is 0, so we have 1 over 1. So therefore, the answer there, it's 1. Next, evaluate the limit of the partial sums of the given series. So the series, this is an example of an infinite series, particularly on a geometric series. No? So if we try to check for the terms, we have, so let's say 36 over 108, 12 over 36, 4 over 12. We have a common ratio of 1/3. Okay, we have a common ratio of 1/3. So we know that the formula of an infinite geometric sequence that is defined by a sub 1 over 1 minus r. So we have a sub 1 is 108 divided by 1 minus 1/3 is 2/3, so that is 108 times 3/2, and we will get 162. So the answer here is 162. Okay, for this one, all you have to do is to, this is an example of an arithmetic sequence. So all you have to do is to add 4. So plus 4, you have 19, plus 4, you have 23, plus 4, you have 27. So therefore, the sixth term is 27. Okay, find the first 10 terms of the geometric progression. So if you recall back your lesson in algebra on geometric progression, so just simply apply the formula, no? A sub 1 times 1 minus r to the power of n all over 1 minus r. So actually we will get 2046 for this one. So A is the answer here. The next item. So which of the following best describe the given sequence? Okay, is it bounded? So if it's bounded, it should have a limit. So you have there e to the power of n over n. So it's hard to identify, no? So if we try to determine the limit, uh, so that it's infinity over infinity. So we have an indeterminate form. So for this one, you have to apply the L'Hopital's rule. So if we apply the L'Hopital's rule, derivative of e to the n is e to the n also. Derivative of n is equal to 1, so we have e to the n. So the limit of e to the n is infinity. So therefore, that is infinite. So therefore, that is not bounded. So A here is false. Is it monotonic? Okay, this one, this sequence is uh, increasing. So this is increasing, therefore it's monotonic. So therefore, letter B is the correct answer. Convergent, it is not convergent since it is not bounded. Okay, number 2. Which of the following is true about the sequence? Okay, is it convergent? Okay, so does it converge ba? So if we try to evaluate the limit is approaching to 0. Ano? So the maximum the value of sine pi over x, the maximum and the minimum value is between 0 to 1. No? And 1 over n, it's n. So we can sandwich there 0 and 1 over n. So therefore, as 1 over n approaches to infinity, so therefore this whole sequence will also approach to 0. So n approaches infinity, this whole sequence will approach to 0. So therefore, it is convergent and bounded. Is it monotonic? No, because that is a sinusoidal sequence. It's an alternating sequence. So therefore, it's neither monotonic nor increasing. Therefore, the correct answer here is 1 or 3. So 1 and 3 is the correct answer here. Which of the following series is convergent? Okay, we know that the series is convergent if we have here an example. Okay, this is near to a P series, no? Near to a P series. Okay, number 1, it's divergent since n here is equal to 1. So here, in this case, option 1 is divergent. Here, 1 over n squared plus 1 is close to 1 over n squared, and 1 over n squared is a P series. We know that if P is equal to 2, then the series will converge. So therefore, option 2 is convergent. 3 here is divergent since the value here will come to 1 and positive 1. 1, positive 1, 1, positive 1. Here also, this is going to infinity, so therefore it's not convergent. Only option 2 here is convergent. Which of the following series is divergent? Okay, 1 is convergent. Number 2 is convergent also. The common ratio here is 1/3. This is number 2 is a geometric series, no? And the common ratio is 1/3. So therefore, this is also convergent. Number 1, if we try to evaluate the limit of the sequence, it's equal to 3. So if the limit of the sequence is approaching to some limit, though its sequence is convergent, but since it is not equal to 0, so therefore automatic, this is divergent. So only option 3 here is divergent. Option 4, if we apply integral test, that option 4 is convergent. So option 3 is the correct answer here. Which of the following is a lower bound of the sequence? N modulo 5. So n modulo 5, the values of that is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And the value lower than 0, 1, 2, 3, 4 is negative 4. So therefore, negative 4 is the lower bound for these options. Which of the following is not true about the convergent positive series? So its partial sums have an upper bound. Of course, yes, it's an upper bound, no? Okay, it goes to a particular limit. It corresponds to its corresponding sequence is also convergent. Yes, it's convergent to 0. The limit of its partial sums is equal to some value of s. Yes. No? So there is a particular limit for the partial sums. So the limit of the corresponding sequence is equal to some value L. Okay. So here, the only thing that is false here is letter D. It should be equal to 0. No? Convergent sequence, the value is 0. The, the limit of the sequence of a given series is equal to 0. But not the other way around. If the other way around, that is subject for testing. So therefore, the only thing that is false here is option 4. So therefore 4 is the answer.